We're given the reaction of fluorine with ammonia, producing dinitrogen tetrafluoride and hydrogen fluoride. We need to balance this, so I'm going to copy this over here. Got a little bit more room. Let's separate the reactants from the products. Two fluorines in the reactants, one nitrogen, and three hydrogens over to the product side. Let's go side by side. We got four fluorines, two nitrogens, and one. Actually, fluorine shows up in two different locations. So that second line is for the fluorine in the hydrogen fluoride. So it looks good now. We'll save the fluorines for later, because if an element shows up in multiple places on either reactant or products, then better off to do that last, especially because one of it's just all isolated on the left side. So just keep that in mind. We're going to need even numbers of fluorines on the right side, and we don't. Yikes. All right, what can we do? Let's see. This fluorine is, well, they're both connected to other elements. All right, balance the nitrogen first. We're going to put a 2 to balance out the nitrogen, update that hydrogen that's connected to that nitrogen, and that's going to give us 6. Now we can go to the product side, balance out the hydrogen, put a 6 there as a coefficient, get that hydrogen balance. Let's update that fluorine as well. All right, so that works out. We got 10 fluorines now, and we can go back here and put a 5. We are done. Put the 1 there just for the visual. 5, 2, 1, and 6. All right, part A. We got, if you have 66.6 grams of ammonia, that is right there. That's the reactant. How many grams of, right, the other reactant is required for a complete reaction? Okay, no wasting ingredients. All right, let's start with what we're given. Given 66.6 grams. Convert that to moles. We're going to need the molar mass. And we need that set up where the grams cancel out, because we're trying to get to moles. That's step 1. All right, do the work off to the side here. Nitrogen has a molar mass of 14.0. Hydrogen has a molar mass of 1.01. There's 3 of them. Gives us 3.03. I'm just going to go with 3 sig figs here because I'm trying to get through these answers for you all. 17.0 is the molar mass for ammonia. All right, step 2, mole ratio. Now this is where we are going to convert to the desired substance. Right now we are, in terms of ammonia, we need to get that to substance of fluorine. That's a 2:5 ratio. Give myself a little bit more room. Right, ammonia's got to go on the bottom to cancel out the ammonia on the top. And I believe it was a 5:2. Let me just go back and check. Yeah, 5:2. So the last step in Stoich is to convert to the desired unit. So again, right now we have units of moles. We need to cancel that out. So put that on the other side of your conversion factor. And fluorine has a molar mass of 19. There's 2 of them. 19.0. That's going to give us 38.0 grams per mole. Cancel, cancel, calculator. 66.6 divided by 17 times 5 divided by 2, excuse me, times 38. We're going to need 3 significant figures. Answer is 372 grams. Part B, we are asked how many grams of ammonia, and we're given the mass of one of the products. So we're going from hydrogen fluoride mass to mass of one of the reactants, ammonia. Okay, let's start with what we're given, 4.65. Grams of hydrogen fluoride. What's the first step? Get rid of grams and turn that into moles, right? Convert to moles, because moles can get you anywhere else. All right, let's do our work down here. Hydrogen has a molar mass of 1.01. Fluorine has a mass of 19.0. That's going to be 20.0. 20.0 molar mass of hydrogen fluoride. Cancel, cancel. Step 2, mole ratio. We want to get rid of our information in terms of what we were given, which is hydrogen fluoride, and we want to end up with values in terms of what we're asked for is ammonia. I believe it was 6 to 2. Yeah, 6 to 2. 6 moles to 2 moles. Cancel, cancel. Finally, let's turn that into grams of ammonia. 1 mole of ammonia has a molar mass of, we just did this earlier, okay, 17.0 grams of ammonia. Cancel, cancel, calculator. .65 divided by 20 times 2 divided by 6 times 17. That's it. 3 significant figures, 1.32 grams of ammonia. Moving on to part C. How many grams of dinitrogen tetrafluoride can be produced? 225 grams of fluorine. Okay, so now we're given this reactant, 225 grams of it, and asked how much of that product can we make. All right, start with what we're given, 225 grams fluorine. What else would you start with? Okay, fluorine, we just did that earlier. It's up here, molar mass, 19 times 2, because there's 2 fluorines. Grams is in 1 mole. First step in Stoich, convert to moles, because then you can convert to the desired substance, which is, moles of fluorine has to go down here. And I forget what, I think it was moles of dinitrogen tetrafluoride, was it? Yeah. Okay, what was it? 1 to 5 ratio, mole ratio. Cancel, cancel. Oh boy, I should have known they were going to do this. All right, not too bad. Not too bad. Here we go. Nitrogen, molar mass of 14.0. There's 2 of them. There's 28.0. Fluorine, 19.0 times 4 of them. All right, 20 times 4 is 80, minus 4 is 76. All right, add them up. 90, 104. All right, so 1 mole. So 1 mole of dinitrogen tetrafluoride has a mass of 104 grams. Cancel, cancel, calculator. $225 divided by 38 divided by 5 times 104. 3 significant figures. 1, 2, 3 grams of dinitrogen tetrafluoride. This should be a 4.